return on investment comes. And I think a misconception is how expensive it can be to implement, and it's not.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be once again joined by my colleague Tom from the Senseye Solution Engineering team within Siemens, becoming a regular fixture on the podcast, which is really good to see. We've covered lots of really cool topics so far. And today we're going to hopefully add to that list with we're going to talk about breaking down predictive maintenance for non-experts. So actually this one's maybe targeted at someone like me as well, someone who's non-technical, but just really wants to understand sort of the fundamentals of it, which is, of course, very important in any organisation as well when you're thinking about deploying this technology. So, welcome, Tom, and thanks for coming on.
Hello. So, yes, brilliant. It's good to be here.
Fantastic. Well, let's get straight into it. No need to mess around. So when you're in that situation, Tom, it must happen to you every day, every week, every month, where you're sort of introducing predictive maintenance who maybe don't fully understand the concept, or maybe they think they do, and they and you find out that they don't. But how do you typically start to try and sort of explain that and break that down on that sort of non-technical level, if you want to call it that?
Yeah, it does. I mean, every couple of weeks we come across this where there's customers who don't necessarily understand what PDM is. And I like to start framing it around, a simple analogy, a relatable analogy that you can think of, something like your car. So imagine instead of waiting for the engine to fail or changing the oil every, 10,000 miles, regardless of condition, basically what we're trying to do is tell you what's happening to the machine. In this instance, it's your car, and say that basically we do this on an industrial scale. So the whole idea of this is to give you early warnings, to spot early warnings before problems escalate, and ideally capture failures before they become problematic and they cause a downtime, like a collapsing bearing or something you'd find in your car, something you'd equally find on scale, across industry. The whole idea is to capture things before they become problematic.
And does that resonate? I mean, is that instantly understood, or is it still? I mean, and I guess maybe a different angle to look at it is, why is there sort of a misconception of it? Do you think there's a lot of marketing noise? People like me to blame for labelling everything as predictive maintenance. Does that sort of add to that confusion?
It doesn't. I think a lot of it comes down to understanding what the business requirement is. So quite often, predictive maintenance is based on algorithms and sensor and data types, but it's actually, those things are irrelevant in terms of business objectives. What you're trying to do is understand what are the key things you're trying to mitigate. So is it downtime you're trying to avoid, or move away from time-based maintenance? A lot of it is really coming down to what's the business requirement for this.
And I know I was doing a podcast recording. I mean, it comes up in a lot of podcast recording, but it's that sort of shift away from focusing so much on the technology, because the temptation is to go, let's look at the technology, how cool it is and what it does, without actually thinking of, how is this going to solve, my business problems? Is that sort of often the case?
Yes, exactly. So if you can think about it as exactly that, you're trying to think, what's it going to solve? What's the objective technically? There are things it's going to do, but actually for the business, it will impact you in many different ways. So how much does it cost when your plant shuts down? How much does it cost when a big truck in a mine isn't operational, or a palletizer in a pharmaceutical factory stops running? These are the kind of things that maybe no single person or no single group of people have in a factory or in a facility. You need to have all the data, first of all, centralized so you can make smart decisions on those different things. And that's really hard to do. Obviously, industry is going in that direction, which is brilliant. It starts to alleviate some of those misconceptions. You start to understand more clearly what's the point of having an analytics tool, a SaaS-based software that can make sense of all that information that you've suddenly collected into one place.
And in terms of those, we talked about people's perception of predictive maintenance, but what are some of those sort of misconceptions that people have when you first sort of introduce the topic? What comes to their minds? mostly?
I think a lot of it, that's a great question. I think a lot of it comes down to suddenly thinking you need to add all these sensors and collect data, kind of what I'm talking about here, to have an overview. More often than not, that data is already available. It's in frequency converters, it's in other data that you've already got available. At the moment, you might not do anything with it, or there might not be a network in place or a method of data collection from different PLC cabinets across a facility. And all it comes down to is doing that last little piece of work to centralize data, put a network in place, add some LoRaWAN sensors or some connectivity of some form. And that does the last little piece that you need. You don't need to start from scratch. And that, I think, is one of the biggest misconceptions. I think one of the other ones is how long it could take for return of investment. So if you understand what downtime costs, or all those extra changes of components and things that do inherently cost you a fortune without you knowing it, so how do you put a price on that? It's very difficult. That is really important because it allows you to see quite quickly if we don't waste our time doing loads of grease samples, if we don't waste our time doing loads of over maintenance or time-based maintenance, we just do the work as and when it's needed, which is the methodology of predictive maintenance. And of course, we also don't allow things to break as much as possible. We avoid that downtime. Again, that's increased uptime, increased productivity of certain machinery. It's quite incredible, and customers see this, how quickly return on investment comes. And I think a misconception is how expensive it can be to implement, and it's not.
Yeah, because I guess quite often it's that, that the first thoughts turn towards sensors. Is it because they've maybe underestimated the amount of data they actually have, in terms of data that can be used to enable predictive maintenance? Is that why they automatically, think towards that, that way, or is that not the case?
It can be. Yeah, I think it can be. Sometimes you don't realize how much equipment you've got, how many smart pieces of equipment you've got across the factory already. Even something as simple as a small sensor that does a small little thing in one corner of the room. It could be ambient temperature. Maybe that changes the viscosity of fluids, and it does lots of different things across a hydraulic system or lubrication system. And you actually can't see the correlation. And then there's loads of other parts of the factory where you can't see correlation between motor spin speed and oscillations on a bearing or something like this. A lot of that stuff isn't in one place.
And I guess from my perspective as well, when you choose to sort of add sensors and collect data, do you find with some customers, all customers, a few customers, where they put sensors on machines and stuff, but is there a strategy behind it? I guess if are they thinking of I want to monitor energy, or I want to enable predictive maintenance, or is it just a case of we better collect some data to be digital? Does that make sense?
It makes sense. Yeah, I think for a long time there's been an over stimulus on trying to have data of every kind. So we need to suddenly pepper our machines in vibration sensors. In some cases, it will add value, and in other cases, it brings you basically nothing. The data is either already available, or in some cases, we've seen it where the wrong sensors get implemented. You have to go to them with a handheld device to get the readings, and someone has to do that on a time-based maintenance approach. And we would recommend something different. But what I would tell people is just to keep it simple. We've got engineers designed within the process, so that we can scope a system, we can have a look at it, we come and see the machinery, we travel wherever it's necessary, to look at the machines, to understand what's required, understand what is missing from that application. Maybe it's vibration, maybe it's something else. Maybe it's something as simple as a person on the team. We say, right, do you guys have a reliability engineer in place for this stuff? Or do you have an approach already in place to kind of to hit this business objective? Sometimes they do, and quite often actually it's a team of people who are thinking in that direction. They've got all the right ambitions, and it's just a case of, okay, what's the approach we're going to take? What next steps do we need to get us over the line, or to start a small pilot project with 50 assets or 100 assets, whatever it is. Yeah.
So I guess maybe it's the fact that that people have a lot of the fundamentals in place, like data and maybe some drive to change, make culture or maintenance practices within an organisation, but they just don't know which way to go or how best to approach it. Maybe especially when they've got everything else going on in their in their day, which it's difficult to put all that together yourself, right?
That's exactly right. And digital transformation, there's lots of different facets to that. You could simulate your process. You could do digital twins. And in some ways, you might be doing the wrong thing. It can be very difficult to understand the best thing that you need for your application. Maybe you think you need, you've seen the virtual headsets and you need to send everyone on a virtual training course on how to do something. That can be really helpful, but there can be, from my perspective, predictive maintenance is a fundamental place to start to optimize the maintenance team. You already do maintenance. You already change components, spend money on spare parts. But how strategic do you do that? How strategic is that approach that you currently take? And that's really what we're trying to do, is we're trying to bring customers on that journey to explain it and show them. And almost all customers, I would say, if not all customers who start a pilot, then continue, because it proves itself with the technology and the approach, centralization of data and all the other stuff that we just talked about.
And actually, that leads on quite nicely to that key aspect, return on investment, and especially, and you'll know better than me, but quick wins, to build confidence in predictive maintenance, because we all know trust and confidence in what the system's delivering is very important. I'm sure you'll agree, but maybe you've got Tom some examples to share around that from customers.
I think some of it is about workflow integration. So some of it is we've got this process already in place. We want to have an addition to that enhances it in some way. So it gives us alerts on when certain components are about to, hit critical mass and break down. We're going to try and forecast that, or we're just going to have an understanding of that deviation away from normal. Take something as simple as a bearing to understand, how is that breaking down? What's the simplest proof point that we've got to show customers? And I think if you take away all of the technology, take away all of the stuff that complicates things, and you just sit there with the team and you say, right, guys, what's the objective? Are you trying to save £100,000 a year? Are you trying to optimize and speed up the process so you can do more with less? Often what we find is that this is not to replace members of staff. It's to make sure that what gets done across the workplace gets done more effectively. So you do a better job of fixing a gearbox, or you do a better job of, greasing certain elements of a process at the right times in advance before it becomes problematic. Does that? I'm not sure that answers the question, but I think that's.
No, I think it does, or at least it sort of brings another area in time. So, I mean, how when you're sort of and that's the key to it all. Talking, having workshops and really understanding this. But how hard is it from your perspective, sort of tease out that information? Because sometimes it is quite difficult, overwhelming to think, where do we want to focus first? What do we want to achieve above all? But how hard is it sort of to tease out that information from potential customers?
I think the information is not such a problem. It comes down quite often to the approach and the culture. So if the culture is to brush things under the carpet and hope they don't never, rear their heads again, that can be something that we have to try and mitigate first to make predictive maintenance make sense, to make that become a proactive approach to maintenance and to the way we operate, the way we fill in an alert that's popped up to say how it's fixed. We need to make sure the culture is right. And then I think if management are driving this from the top, it can be sometimes in a really nice way, in a really kind of optimistic, proactive, guys, explore the market, see what you can find. We need a solution that can do this. Sometimes it can be the opposite. It could be, right, at all costs, go out there, we're going to force you to go and find a solution. You sort of need buy-in from the people who we're speaking to. So you need to have the people involved empowered. They need to feel that going out there and searching for a predictive maintenance solution makes sense, and it's going to offer them something. It's going to benefit the way they do their work on a daily basis. They don't feel it's going to replace them. They don't feel it's going to negatively impact anything. It's going to enhance the way things work. We've got use cases, we've got case studies, all sorts of different things from other customers where they will tell you firsthand Senseye is a brilliant tool. It does exactly what it says on the tin, and far more than we expected. That's a plug for Senseye, but I really believe in this tool because it's so good at being able to centralize data. Take the live telemetry of the machine, take the historical telemetry of the machine, look through the knowledge tab. So new feature within Senseye is the knowledge tab. So you have PDF documentation, user manual, all the script from how the machine's supposed to work, when it's supposed to be maintained, what tools you need, what lubrication you might need for that application. And all of that stuff is fed into one algorithm effectively using large language models, artificial intelligence of various forms, mathematical models to analyze peaks in the data and all the rest of it. All of that stuff combined puts you in a position. I honestly believe Senseye is the best product in the market for doing this and give you a holistic overview of what the machine is doing, what you need to do in terms of making decisions and having some support in making those decisions. I think the best thing to do is really come and speak to us and speak to me, speak to the rest of the solutions engineering team. We'll pitch the solution. We'll show you how it works. We can show you, the way it solves problems with other customers. And I say that really in every different industry out there. We've got use cases, pretty much all of them on how we do this.
No, you did a good job selling it there, Tom. Very, very good. Very good. It's like you've done this before, once or twice.
Yeah.
But that, and exactly. And I guess the question comes as well when we come back to the topic of for non-experts, and what also springs to mind is, sort of generative AI and co-pilots, and how is that breaking down some of those barriers, especially to non-experts, who maybe, aren't data scientists, reading graphs and things, but actually, have natural language now summarizing what's happening. How has that made sort of a difference on that front?
Copilot, I think, is single-handedly solving one of the biggest problems in industry at the moment, which is we don't have the very, very good and skilled, multi-decade experienced, maintenance engineers that we had in the past. Which means in every industry, arguably every industry out there, there's a lack of maintenance knowledge. And that just comes down to there being a massive data. Lots of things have to happen very, very quickly. It's very hard to be an expert, on all these different things when you're kind of new to a process. You've been brought in, maybe you didn't do your apprenticeship there and spend years and years and years doing that process. Copilot now makes that, much easier because it allows someone who's 1 month into the job have the ability to interrogate a system, ask questions, understand the problem more deeply, understand how that's happened in the past, and it gives you an insight that you don't have by just looking at a motor or looking at a mechanical component in a factory with a toolbox and you just don't know where to start. Lots of things, let's be honest, these days are mechanical and electronical. So anything that's mechatronics, effectively, like a car, take a car from 50 years ago that wasn't so, littered with sensors. Anybody could work on it, and it was much easier to maintain in many ways and to do that work yourself. Machines have gone in the same direction, so there's lots of machinery that you can't just diagnose the fault quickly. And having this decision support tool, amongst other things within Senseye, plus the ability to link that to your workflow, it's a world apart from where maintenance teams were, even just a few years ago, let alone, 5, 10, 15 years ago. So it fills a big skills gap. No, I think is the best answer to that.
Yeah, no, exactly. Because we'll know, everyone speaking to, with there's skills gaps, there's people leaving businesses and not being replaced. So it's really as well on the, capturing the knowledge part, knowledge that would normally be in someone's head, or maybe, like you say, gathering dust in a manual. I would say in a cupboard, but that's probably not the modern way. More, I don't know, in a file sharing system. I don't know, somewhere.
But that is how it is. And often when you're under pressure, you need to, you got other things to fix, other things to do. Who is going off to find, that exact manual from 25 years ago when that machine last failed in that way? It's a case of having it in a digital form that the system can utilize, for lots of different benefits.
But I guess back to that point about, sort of, hesitancy to adopt or believing in what the insight are saying. I mean, has like co-pilots and Gen AI, is that sort of helpful for that? Does it make it more? I only think from my point of view, it's an easier concept to understand. And it's like in a natural human, obviously written language as well, which would to me feel more trustworthy. It's a bit of a weird way to say it, but does that make sense?
I think having the ability to almost have it sounds weird, but like a human to human conversation
Yeah.
and understand and ask, what's wrong with you? What can we do to fix these certain issues that you've got? It sounds weird, but of course we are going to go in that direction as AI develops and as the industry, it of course develops. But to have a machine that can effectively diagnose its own problems and tell you what it needs, what the medicine is that it needs to fix it, it's an absolute game changer. We've never been able to have that level of decision support ever, and that's a fantastic use of modern day artificial intelligence and all the other things that go alongside it. Because actually, Senseye was a brilliant tool before Copilot. To keep it simple, what it's doing in terms of being an agnostic solution without models, with a solution that really captures information of different types from different machines. If it's rotating or non-rotating. This is again why it's simple, because you set that in play, it does its job, it collects some information, and it builds a fingerprint of what the asset should do, what they normally should do. Maybe they produce 5 different products. Yeah, we can factor that in. And then it does different things on different patterns, different shifts or whatever. We can factor all that stuff in. And then it can learn very quickly, which makes it very scalable. It means if you've got thousands of machines in multiple sites across the world, or you've got hundreds of machines, or you've even just got tens of conveyor belts that all do similar jobs, it works for any company, regardless of what the business objective is. And I would argue that Senseye could do that. It could solve those problems in an enormous array of different applications.
Yeah, and actually, right, and a wide range of use cases. So I referenced an example you gave on a previous podcast as well, which because everyone thinks about predictive maintenance in terms of saving, making maintenance teams more productive or saving unplanned downtime. But I remember you mentioned a very specific example around health and safety, which obviously is priceless. There's no price on that, but it was just interesting how that came up as a real sort of point of focus for a particular client you were speaking to.
And that's a good example because I could mention it again. The health and safety point of it is really important. If something becomes a hazard that maybe you don't realize it's a hazard, it could be mitigated before it becomes problematic, saving someone a limb or whatever it could be. There's all sorts of knock-on effects. We often get asked, does it affect the process? Like, does this make us more effective with the process? Secondarily, I would say yes, in some cases, depending what the asset is, what the job is that it does. So safety is one knock-on effect of maintaining and having predictive maintenance in place. But also, secondary things like if we do things this way or we keep the machine healthy in this way, the product quality improves, or the way the process gets towards its end on a production line or in a mine or whatever it is, inherently gets better. And this is why I think predictive maintenance on a digital transformation journey is a really good place to start, because it has loads of other knock-on effects and it can spearhead a digital transformation journey. I think way more than people think it can. Often people think, oh, well, we don't have any of this stuff or that stuff and we're not ready. It seems like predictive maintenance is way up here on the pyramid and we're just starting out on our journey. We've seen customers where it becomes the reason to optimize lots of other things, to centralize data, to put a network in, to collect IoT sensor information or whatever it is. So there's loads of other benefits, not just obviously quote unquote the maintenance part.
Exactly, definitely. So as we sort of come towards the end, I think we've covered quite a lot in such a short space. It's been really great. I guess just like we like to do on the podcast is just sort of summarize in terms of, let's picture it, a skeptical client who, about the benefits, predictive maintenance, unsure whether it's for them, whether they should be thinking about it. What would you say to that particular client, without knowing their particular circumstances, of course, but in more general terms, Tom?
I think one of the key things is that it doesn't replace human expertise. It's an addition. So a lot of what we're trying to do is build on what already exists, what's already in place, and to make the best use of the tools we've got available, be that data manuals, data or user manuals, whatever it is, and to just really try to affect the business in some positive ways. So there are going to be skeptics, but I think there's so much evidence out there now, especially of our own benefit across the industry in general, that predictive maintenance really works. It's almost, it gets called magic. Noel, you've heard it yourself many times. And it seems too good to be true that with a piece of software, you can have a real mechanical impact that saves a production line days of outage or whatever. And it really can. We've got the use cases. I'm sure you can point people in that direction as to where this has worked.
Absolutely. Yeah. I mean, just check out our website. It's in the link in the show notes. We've got, even episodes. I get very excited over a particular episode I did with our customer BlueScope Steel in Australia, talking about, they saved, I think it's 24 hours of unplanned downtime, but with the extra layer on top of it, the co-pilot actually, helped to direct them towards or advise on the best approach for it. Because I think, again, that was to do with safety as well, doing it at the right time, approaching it in the right way. And again, the co-pilot helped with that side of things as well. So, maybe we'll link to that in the show notes, because it's a great customer as well, of course. But yeah, really great example there of the power of what you've been talking about so enthusiastically today, Tom.
Yeah, and I think that's another one where that kind of customer, especially BlueScope, would positively speak if there's anyone who's skeptical, really skeptical, and they want to hear more about how it's affecting things. Reading that kind of stuff is very, very useful. But I think a lot of customers also like to speak to other customers and say, "Hey guys, how did you use it? How did it really benefit you?" Senseye will be Senseye bias, of course, but it's getting an opinion that's not so biased.
Yeah, no, that's a really important point as well. Absolutely. So no, I think that's a really good way to sort of summarize and finish this episode. But yeah, we've covered a lot. Of course, like Tom said, feel free to connect with him directly through LinkedIn or other means, or through our website and all the usual channels as well. Because that's the key to all this is you don't need to know everything, right? That's why you work with a vendor like Siemens or other vendors as well, of course, to help work this out with you together. What's the right approach? Which data to collect? Which what key challenges are you trying to solve, and how can we help to do that? So yeah, that'd be my sort of takeaway from that. But for today, Tom, as usual, very good to chat, and thanks for sharing your sort of expertise with the audience today. Really appreciate you coming on again, and we'll certainly have you back on soon.
Fantastic. Yeah, thank you. Anytime, reach out if it's on LinkedIn. We're also going to be at Hanover Messe in April. Feel free to come along. And of course, also, online meetings, always welcome. We can also visit you if you've got any questions or you want us to have a look at the application itself. Feel free.
Fantastic. Yeah, thank you, Tom. And thank you everyone out there for listening to this episode, and we'll see you on the next one. Thank you very much.
Cheers. Bye.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.